Hello students, welcome back. So now we are going to be learning about MLflow. So why do we need MLflow? Well, suppose you're training multiple models. Well, how do you know, how do you track like which one of these models are good, which one of them are not good? Well, this is where your MLflow comes in. It acts like a GitHub for your machine learning models. And this is what real companies they do. They don't just train machine learning models. What they do is that they keep a track of your machine learning models, they compare all the models, and they also promote the best models automatically. And this is where your MLflow comes. It helps you do all these three things together: track, compare, and promote the best model. So in MLflow, it helps you track experiments, it logs the parameters and also your metrics, also stores the model, and it helps you deploy your models. So the flow in MLflow is something like this. Suppose you have these two models, model 1 and model 2. You train these models. That's your first step. Second step would be you track this model 1 and model 2. You try to see how their parameters are, how their metrics are. Basically, you try to look at those things. And then you save the best model. So between model 1 and model 2, maybe you save model 1. Maybe model 1 is doing good. And then at the end, you deploy the best model. So the first thing you're going to do is installation. So in my case, I'm using Python 3.12. So first thing I'm doing, I'm creating and activating my environment. So my Python 3.12, this is the path of that. And I call this Python and I use -m venv.venv. I run this command that's going to create a Python venv environment for me. So you can just come over here and let me just show you. I'm just going to copy this and my files are over here. So I have this directory MLflow. This is where all my code is going to be. You can just right click and open up in a new terminal over here. And let me increase the size of the screen so you can see. There you go. And let me make it a little bit bigger. There you go. And there you go. So this I just copied and pasted this and hit enter. And that's going to create your virtual environment. I'm not doing this thing because I already done this thing before. It takes some time. Okay. And then after that, okay, let's just come here. Okay, assuming you have done that now, next step is you want to activate your virtual environment. So let's go ahead and activate my virtual environment. Just come here and I'm just going to copy and paste that command. So copy and come over here and paste it and hit enter. And there you go. You can see my virtual environment has been activated. Okay, next step. So I'm installing necessary packages. So these are the packages. First, I'm upgrading my PIP. That's the first thing I did. And after that, I installed these packages. So just be aware, like first time when I ran this thing, it gave me some issues. So I finally figured out that I had to run these types of, these are the installation I had to perform. So I had to install MLflow 3.10.1, scikit-learn this and this right here. So when you run this, this will install all the necessary packages. And then over here, and then I freeze my package right here. I'm putting all the packages that I installed into requirement.txt. Then I start my Jupyter notebook. So this is how you start that. So this step right here, I'm already done that. It took me like 10-15 minutes. So I was not doing this thing, but you can just copy and paste this command. And this is going to install your Python all these packages over there. All right, so let's go ahead and start the Jupyter notebook now. So I'm going to Control C, come over here and paste it, hit enter, and just wait for it. And that should start your Jupyter notebook. Okay, so the Jupyter notebook has is started and running, and so this is the directory where the code is. So step one, I'm going to be doing some model comparison. So let's click on this, and let me show you the code, what I'm doing over here. So first thing I did, I import my necessary libraries. I'm importing MLflow, mlflow.sklearn, and I'm also importing these libraries right here. So let me just go ahead and run this. And this will actually import my load iris dataset. Also, I'm using train test split to split my data into training and testing. And I'll be using random forest classifier. Also, I'm using SVC. So I'm going to compare how my random forest classifier and SVC do against each other. Okay, so let's create an experiment name. So the way you do this thing, you always create an experiment name. So in this case, I'm calling my experiment name as this: model compare RF versus SVM version 1. Okay, so this is the name of my experiment. I set up my experiment name, and then I'm calling my load iris. So this is going to load my iris data set. Then over here, I'm splitting my data into training and testing part. So let's go ahead and run this and just wait for it. And there you go. So I get some warning, some information messages. All right, that's fine. Nothing wrong with that. Okay, this is good. All right, now okay, the cell is ran successfully. Now I'm going to define a function. And this function is responsible for taking this model and the model name and the parameters, and it's gonna train that model. So in this case, I'm gonna call mlflow.startrun, and the name of the model would be this right here. And then these are the parameters. So the parameters I'll be specifying. So in my case, let's just come over here. My parameters are right here. These are the parameters. So I'm calling this function twice. So you specify the parameters of the model, and then you train the model right here, and then you calculate its score. It retrieves the score, and then you log whatever score you got from your model. You put it inside the MLflow, and there's an inbuilt method called log parameters, and you specify your parameters over here. So the whatever parameters you pass to your model, also you can specify your this is a log metric. So here you can log in your metrics. So my metric in this case, let's say, is ACC, which is accuracy. So I'm logging in accuracy. You can add some more metrics over here if you want to. And I'm also putting a tag over here. So in this case, my tag is model name and then whatever the name of the model is. And then I'm calling MLflow sklearn.log model. I'm also logging the model right here. So in this case, I'm saying model, that would be the model that's passed over here. And the name, I'm giving it name right here. Serialization format, I'm using scops because I was getting some warnings. So I had to run this thing in order to stop getting those warnings. Okay, then after I define this function right here, I call the function. So the first one I'm doing is random forest classifier, and I'm calling it random forest, and these are the parameters right here. And then I'm also calling SVC classifier, and in this case, this is my parameter right here. So I run this, and this took me approximately, I want to say, 10 seconds. Yeah, 10 seconds to run. So just have patience, and there you go. It's still running. And let me just pause the screen and come back when it's done. Okay, so the model ran successfully, and this is the message I got. I got some few warnings, and at the end, I got this clean comparison done right here. I got the print message. All right, this is good. Next step, now I'm going to access one of the models through its API endpoint. Well, before I do that, let me show you what's the next thing I do. So I ran this thing, and so come back over here now. Now I'm going to open up my new terminal and run this in terminal, this Python minus m mflow UI. So this is going to open up your MLflow user interface. So let's go ahead, let's come over here and, not this one, come over here, and I'm going to open up a new terminal over here. All right, I'm going to activate the virtual environment. In my case, I'm using virtual environment, that's why I'm activating it. But in case if you're not using it, then you don't have to do all this. Scripts, activate. Let me just increase the size of the screen so you can see what I'm doing. All right. Okay, and then, okay, let me just, there you go. And now I'm going to run this. Make sure that you have internet connection when you run this, otherwise you're going to get an issue. So run this in the terminal. Also, it should be in the same directory that contains the code. So two conditions needs to be satisfied. First, internet connection, and the other thing is make sure this is exactly in the same directory that contains the code. So go to that directory. That would be your MLflow. All right, and paste that command and hit enter, and that should open up your MLflow user interface in a minute. There you go. All right, so it's telling you UVCon server is running at this port right here. So go ahead, click on this. So I come to that particular URL, that is 127.0.0.1 colon 5000. That is the port. You can do copy and paste. Okay, and this is how the screen looks like in my case. So in this case, this is the one model compare RF versus SVM I just did. Let me show you the code. That was right here. Let me just, that's the one right here. So when I set my experiment name right here, this is the one that's responsible for creating this model compare. Okay, let's go ahead and click on this, and let's see what it gives us. It gives you these two models, SVM and random forest. So that's the one we just trained right here. Okay, I actually ran random forest, and I also ran SVM right here. Okay, come back over here. Now let's click on this SVM just to see what's it showing. So you see, for SVM is showing me metrics, accuracy. For parameter is showing me kernel RBF. For logged model is showing me these information. And the reason it's showing me this is because manually I specified in the code, I specified over here that log my parameters right here, and log metric I want to see accuracy, and my model name would be this right here, and log model is this right here. So because of these three information, because of these three lines of code, it is logging all this information over there. So coming back over here, you can see that where is the tag? You can see that model name is SVM. You're putting a tag over there. So all this information gets entered over here from that line of code. Okay, coming back to this now, let's just come back. Now, let's say you want to compare both the models simultaneously visually. So you can click on both of them and you see this option compare. Go ahead, click on compare, and that's going to compare both the models now. So it tells you certain things about the model, like how much time it took, duration. It tells you, metrics and stuff like that. It tells you, for example, in this case, is accuracy. So one model is giving you this accuracy, the other one is giving you this, and then gives you, okay, no artifacts to display. So it gives you all this information. Now, if you remove one of them, let's say you only want to focus on kernel, so it's going to give you kernel parameter is going to be kernel and metric is going to be accuracy, right? In this case, there's only one metric I'm using, accuracy. You can have other metrics too. All right, coming back to this code right here. Now, next step. All right, where was I? Okay, so now we can compare our models visually, so that your MLflow does that. Now suppose you want to access one of the models through the API endpoints. Now I'm going to show you how you can access just one of the models. So come back over here. Let's say you want to access this one. Let's say you want to access SVM. Okay, so let's go ahead and click on SVM and you want to access this model. So how do you do that? Well, for that you need the run ID. So right here. So this is the information you're going to need. So go ahead, copy this run ID, and what I'm going to do is run this command right here. This right here. This is the one that's responsible for running and serving or creating an API endpoint that will allow other application to access that particular model. So come back over here. I'm going to just paste that right here. Okay, and then you put your run ID over there. What was the number was? So let me just remove this part. This is from the previous session. All right. So this is my run ID. Copy. Come over here. I'm going to remove this run ID and substitute that run ID over here. Okay. So this is my code. Uh, I'm going to run this command on the command line. So come over here and you have to actually open up a new terminal. So just open up a terminal. And since I'm doing everything in a virtual environment, so I'm activating my virtual environment. You don't have to activate a virtual environment if you're not working on that. Okay, venv scripts activate. All right, and you have to make sure you go into that directory wherever your code is. So I'm in that directory now, and I'm going to paste this line right here. So this line is responsible for serving this particular model, and it's going to serve that model on this port. And I'm not using any conda environment, so I'll specify no conda right here. I'm using regular pip. Okay, hit enter, and that should start serving this model, and just wait for it. Okay, so I'm getting this message, UVCon running on this port right here. So let's go ahead and access this port through a request, through a particular code that I wrote. So I'm going to access this model now and come back over here. And now I'm going to access one of the models through its API endpoint. So this is my request right here. So in this case, I'm loading my iris dataset right here, the one I just created. And so this is my X right here. And I'm taking some samples. I'm just taking first two rows. And this is my URL. That would be your HTTP 127.0.0.5002. That's the port. And in this case, you have to specify invocations because this is where the code actually or the model is being served. And then this is the payload that I'll be giving to the model right here, and it's going to send me a response. Make sure your payload looks like this, otherwise it's going to throw an error. So just be aware of that. Okay, response. I'm going to get a response from the model. In this case, I'm sending a post request. Okay, and then I get the status, and then I'm it's going to also printing out the prediction right here. So let's run this, and there you go. You can see that my status code is 200 and my prediction is 00. All right, that's great. Now let's change this to maybe, let's make it 45 to 40 48. Let's see what it does. Let's run this again and look at the prediction 000. All right, what if I change this to, I want to change this to, let's say, 89 to 95 or 96. Let's see what it does. And prediction is 111. All right, great. So it's working. So this particular line of code is able to access that model, the model I just exposed to on the port, and is able to get the inference of that model through the ML flow. That's pretty cool. Now, in industry, they have structured experiments and automated tracking, and also they promote your best model. So this is a practice that's followed in industry. So let's follow that practice. Let's try to do that. So this is my step two right here. So in this case, what I'll be doing some hyperparameter tuning. So first thing I'm doing, importing my necessary libraries. So these are the libraries I'll be using right here, and then I'm setting my experiment right here. So this line right here is responsible for setting up your experiment. Experiment name is hyperparameter tuning, and then over here I'm loading my data set right here, splitting my data into training and testing, and then I'm actually creating two variables called best accuracy and best run ID. So this is going to store the best accuracy of the best run, whichever run you had it right now, or whichever model that you were working with. So let's just come back over here and let me show you. Where is that? All right, and this is the one step two. So this is the line of code. This actually is responsible for importing necessary libraries, and it's still running. Okay, and just wait for it. And there you go. So my experiment is hyperparameter tuning in this case. So let's go ahead and run that, and it's gonna create this experiment right here. Okay, created successfully, no problem. Everything is looking good. So let's load our data set. It loaded successfully. Now, this took me actually around 30 seconds. So let me just explain you what I'm doing over here. So my best accuracy is 0. My best run ID is equal to 0. Initially, I put none, but you can put 0 too. That's fine. And these are my parameter grids right here. So basically, my model that's random forest classifier is going to go through each one of these estimators. Maximum depth would be this, minimum sample would be this, criteria would be this. So it's going to try to find the best parameter among these. So this is a simple one. By the way, you can make it more. You can add some more numbers over here. I just wanted to keep it simple. And let me just run this while I explain. Okay, while that is running, let me explain you the code now. So I go through each parameter right here, and then I say with mflow dot start run, I start my run over here, and I create the random forest classifier with the parameter, with one of the parameters that I just got it from here from this for loop. Train the model, make a prediction, get the accuracy of your model. Let's say you want to get the F1 score. I'm just picking up one score. You can pick up any other thing. If you want precision recall, you can get that one too. So I'm getting accuracy, getting F1 score, and then I'm logging the parameters. Okay, and I'm also logging the metric. The metric that I'm logging is accuracy. I'm also logging F1 score over here, and then I'm also logging the model right here. Okay, and then I'm also this piece of line. What it does, it just checks your best accuracy against the accuracy. So this is responsible for trying to find a model or trying to find a model with the run ID that actually gives you the best accuracy. So if my accuracy, that this current accuracy is higher than the best accuracy, then my best accuracy becomes accuracy. Although, okay, at the end, then I print out my best accuracy, also print out my run ID. So this is the automation process right here. So coming back down here, there you go. My best accuracy that I got was 94%, and this is the best run ID right here. Okay, so let's just okay. Now we create a URI after this. So what I'm doing, I'm registering my model now. Before I did not register, but now I'm doing it. So go ahead, let's run this, and your model has been registered. So right now it is model version 1. So after I register my model, I want to move this model to prediction. Let's say, sorry, to production. So in this case, the way you move it to production, you call this client, and you say set registered model alias, and you specify your name. This is the name of the model. You calling it, and alias you're calling it production, and this is the version that was from here, right there, this one. That would be version 1. So that's the one you're deploying now. So let's go ahead and run this, and your model now has been successfully deployed. Okay, now how do you access this model? It has been deployed now. But to run this, to access this model, let's say you're satisfied with this model, this is the one you want to deploy. So for that, you would have to run this command right here. Okay, and this command is going to allow you to access this model. But before I run this model, let's go ahead and take a look at that user UI first. So come back over here. Let me go to overview. Let's go to, oh, there you go. So you can see that hyperparameter tuning, that's the one, this one. So let's go ahead, click on this, and let's see what is it showing us. So showing me all these runs right here. And so since I did not specify my own run name, by default it's giving me all these run names. So you can see that it gave me 6-second source, it gives me the source, models, and all those things right here. And so this is the one it ran recently. Okay, let's click on one of them. Okay, so this is aged mouse. Okay, this is the name of the model, this is the run, Now, let's say you want to compare all of them. You want to see which one is doing the best. So come back. Let's go back over here, and let's say you select this one, and this one. You select these three models, and let's say you hit on compare, and it tells you a little comparison like how exactly this model does. So this one, let's see, look at these parameters. So this one actually has okay, these are the same parameters. I must have ran this thing back to back. That's why it gave me this. So let's come back over here, and let's just go back to home. All right, hyperparameter tuning. So let's say I want to compare. uh, let's go with this one and this one and this one. Let's say I want to compare these three models. Okay, click on compare, come back down here, and Genie, okay, 335. So okay, there you go. So it tells me that this which model is giving me high accuracy. Well, let's see, this one is giving me a good accuracy right here, 94.7. So this one has a maximum depth of 5 and minimum sample split is 5. All right, so this is a good model right here. Okay, so this is my best model. Is that what I got from my code? Let's go ahead, take a look. Come back over here, and if you remember, we were printing out our best model. Best accuracy was this, and the best run ID was this right here. All right, come back over here. So this model should have that run ID, and if not, you can always just go back and check. Okay, so let's say you pick up this model. Let's say you like this model. Okay, so you like this model because I picked up only those three models. So let's say you like this model. So let's click on this, and this is the model right here. It tells you accuracy and everything. And so let's just go ahead, copy this. Well, actually, I would not be doing this thing. What I'm doing is I have actually upgraded. I have set the best model right here. This code, I have registered the best model. Okay, and this is the one I'm serving, my best model. So come back to your code, sorry, user interface, and right here you are going to see where is your models, and there you go, iris classifier. That's the one. Okay, so this is the one that's going to get registered. Okay, let's look at model registry. So this is the one, iris classifier version 1 production. This is the one that's there. Okay, click on this. Let's see what information is showing me. Description, there's none over there. If you want, you can add some description. Tags, right now, let's see, there is no tags. Okay, you can add a tag over here. All right, now let's just go access that particular best model. So the way you do is you just run this command. One I just showed you. Where is that? There you go. That's the one. This one right here. So this command is responsible for serving your best model. So I'm going to copy this and go to your command line. Not this one, the other one with 5002. That would be this one right here. So I'm going to shut down this one. All right. I'm going to paste this one. And now this is going to give you iris classifier at production on for port 5002. Hit enter and just wait for it. Okay, so your model now is being served at this port, at this particular URL on port 5002. Okay, so let's try to access that model. And so I have the code right here. So I've already ran this code right here. This is the command line. This is the command I ran on the shell on the terminal. And now I'm going to access that. So let's say the input is this. This is the sepal length, sepal width, petal length, petal width, that type of dimension of your flower. And it's going to make a prediction. So let's run this. And there you go. It made a prediction as 0. Great. So I'm able to access that particular, the best model, the one I just created this way. All right. So this is a small elementary introduction to your ML flow. And I hope this session helped.